All right, so this says engineers must consider the diameters of heads when designing helmets. The company, give me 1 second. The company researchers have determined that the population of potential clientele have head diameters that are normally distributed with a mean of 6.3. So if I were to draw the normal curve here, it's going to look something like this, 6.3 right in the middle. Standard deviation of 0.9, I'll just put that off to the side. Due to financial constraints, the helmets will be designed to fit all men except those with head diameters that are in the smallest 0.6% and largest 0.6%. So we're not going to include the bottom 6%, which would be 0.006 written as a decimal, or the top 6%. So what is the minimum head diameter that will fit the clientele? So if I have the area and I'm looking for this x value, we'll call this x1 and x2. I'm going to use the inverse normal function on the calculator. So if I go to second distribution, inverse normal, the first question it asks is the area. That always refers to the area to the left of the value that I'm looking for. So this first one will be straightforward. That's just going to be 0.006. My mean is going to be 6.3 and my standard deviation is going to be 0.9. So if I paste that, then hit enter, I get a minimum head diameter, if we go to one decimal place, of just 4.0. Now the second one's a little trickier, not too bad, but I need to figure out what the area to the left of this value is. Well, if there's 0.006 above it, that must mean there's 99.4% below it, which is the same as 0.994. So that's the area I want to use in the calculator. I'm going to hit second distribution, inverse normal, 0.994, and everything else stays the same. And you'll see I get a maximum head value of 8.6. So maybe somehow these were flipped. I'm not sure. Your decimals look like they're flipped, and the digits are flipped as well. But you should be getting 4.0 and 8.6.